So here is the equations that we had. We have 4a plus 3a plus 4b approximately equal to 9.8, 4a plus b approximately equal to 9.1, and 2a plus 3b approximately equal to 7.0. All these things are approximate. Now let us try to recast this in a way so that we can use linear algebra efficiently. I will just write it in the following way. I have just written, instead of writing 3a plus 4b, I have taken all the coefficients of a as a column vector, multiplied that with a. Similarly, all the coefficients of b as another column vector, multiplied that with b, and the other side, all those measurements, as another vector. So I have this system of equations. Just convince yourself that this is exactly the same as whatever I had shown earlier. But when I put it in this way, you can see that trying to solve this system of linear equations basically means trying to express this vector as a linear combination of these two vectors. Now, when I say it's approximate, when I say it is inconsistent, I basically mean that this vector may not be in a form that can be represented as a linear combination of these two columns. In other words, this vector may not be, I said approximate, so by chance it could be, but typically it will not be something that belongs to the span of these two vectors. So if I consider these two vectors in R3, then it does not belong to the span of these two vectors. These are in R3. Let's look at it in the form of a picture. This picture that you are seeing is possibly the most important picture that you will have to remember all throughout this course. So here is our system. Now, let's understand this picture carefully. I have got these two vectors. I have shown them as these red vectors. This is in R3, so I am just showing them as just two arrows. And that's the origin. This point is the origin. This cyan dot is the origin. There are two arrows that are coming out. One of them is this 342 and the other one of them is 413. This is just a fictitious picture. I am not being very careful with all the numbers, just showing it. Now the measurement vector, this 9.8, 9.1, 7.0, that is this green arrow. Now all the vectors that can be represented exactly as a linear combination of these two, namely the span of those two vectors, the red vectors, that is this pinkish plane. You see, in this case the green vector is not lying on this space. That's why we say that it is inconsistent. Now, what do I mean by saying that I want to solve this inconsistent system? Well, the natural thing is, if you cannot find A and B such that this will be exactly true, at least try to make it as close as possible. In other words, try to find that point on the plane. Remember, every vector in this plane is of the form some A times 342 plus some B times this 413. So try to find that vector which is the closest possible to that. Now you know how to find that, right? What I will do is I will take a light and shine it perpendicularly on this plane. That's what I have done. I have not shown you the light, but when I am shining that light perpendicularly down, it will cast a shadow. And that is the shadow that you are seeing. This kind of purplish arrow is not an arrow really, it is the shadow of this green arrow when the light is shining perpendicularly on this plane. So if this is the direction of the light, then this angle is 90 degrees. So this is perpendicular to the plane. It is perpendicular to every vector on the plane. Then this will be the point closest to that point. That we all know, right? So drop a perpendicular to get the closest point. So what we will do most of the time is to choose A and B such that this side happens to be the point closest to that point. That point on the plane which is closest to our desired point. This I am sure you have recognized as the so-called least squares technique, because when I say distance, I mean the Euclidean distance, so that is sum of squares, square root of that. So you are basically minimizing the Euclidean norm of this vector, and that's why it gives you the orthogonal projection. So it is nothing but the least squares technique. And this is the most important thing that you have to remember in this course.